We started up the hatchery in 2009, so we're just coming off our 15th production season. In terms of animal production, it's hard to find a better example of one that could be vulnerable to coastal acidification. Because oysters, and specifically oyster larvae, are calcifying organisms, they have to have the appropriate acidity in the water to be able to build their shells. And if that gets more acidic, it makes it more hard for them to build those shells. And so as the acidity in the water increases, it makes producing oysters in a hatchery like this even more difficult.
My name is Dale Parsons, 5th generation to run Parsons Seafood. And today I am standing at the original footprint of our clam house that dates back to the early 1900s. I started farming clams when I was in middle school, 13, 14 years old. So ocean acidification is an interesting issue. I would like to say it's changed the food chain a bit in the estuaries.
I'm a 43-year full-time commercial fisherman. We're in Barnegat Light, New Jersey at Viking Village. I'm a fin fisherman, monkfish, bluefish, weakfish, skates, sharks, whatever is available. The Mid-Atlantic is just kind of a highway of species coming and going, so we have to change pretty frequently. A lot of the species are moving off the shore further and moving to the north and the east further, deeper water. Not all, but many commercially important species have started to move away from the Mid-Atlantic coast. It's definitely a trend that continues, and it's accelerating faster, amongst other different changes that we see. I believe it's pH personally, and my personal belief is this pH change is affecting, the fish that are in a larval state. They're not as successful.
In the estuaries, things do not survive and grow like they used to. When I started farming clams, I can take a bottle cap size juvenile clam, put it in the bay in April, and if it's not marketable in November or December, it would certainly be marketable by the following spring. This year would take maybe into the 3rd summer for the same clam to grow to marketable size. And the biggest concern is what has happened to the dominant species of phytoplankton that those clams that have depended on. So clams by nature are limited to a more narrow selection of phytoplankton for food.
Oysters have a 2-part life cycle. In the hatchery, what we're really focused on is taking care of that first part of their life cycle. So you can think of it kind of like a caterpillar butterfly. So oysters have a 2-week larval phase where they swim around in the water. After that, they swim down to the bottom, attach to something, and go through metamorphosis and become what we typically think of when we think of oysters. The larval stage of the oyster's life cycle, which we take care of here in the hatchery, is very sensitive to the acidity of the water. So if the climate continues to change and our waters continue to acidify, then undoubtedly it's going to cause more problems in the oyster industry. So we're at a point now where the kind of natural resiliency of our eastern oyster to tolerate these changes in pH or changes in the level of acidity in the water is within a range that they can deal with. But as that continues and that acidity continues to increase in the water, we're going to get to a point where they can no longer deal with it. The other problem is here in the hatchery, we have the ability to kind of mitigate acidity in the water. We can adjust the water, we can add things to the water to buffer it so that we can kind of get the water a little bit more neutral again. When oysters leave the hatchery, they're still quite small. I mean, the pencil lead out of your pencil is small. And so once they get out in the water, they're completely stuck with what Mother Nature can provide for them. And if we've gotten to a point where the acidity in the water out there is not appropriate for them to make their shells, then the oyster industry is going to be in big trouble.
Whatever phytoplankton was here when the clams were growing well is not here in the same abundance. There's something else here now. We don't know what it is. We're going to take a closer look at it and find out. But it's the water chemistry it's changing, which affects the species of phytoplankton.
I think there's a lot of things we don't even begin to understand, that we've changed in the ocean. There's natural shifts that are going to always occur, but the speed of it now, I think, is unprecedented. I knew what people were catching 40 years before my time, so I have a pretty long timeline. And then to see all these changes in the last 15 years that continue to happen, I think it's important to remember that just because you can't see it underneath the water doesn't mean it's okay. you know, people come here and they see the sunrise, it's real pretty, and they think everything's fine in the ocean. And meanwhile, you know, we have hypoxia events and continuing dropping pH, and that'll affect shell development and all the shellfish. It's just, if you appreciate the ocean, then you need to think about pH change.